Okay, so we're going to be looking at now um, the pollution aspect of the hydrosphere. So this is going to be key question 4, which is water pollution. All right. So these notes are on the blog, but they do come from a textbook that is an AP textbook I used to use. So the notes are online, the readings are online as well in the regular blog spot. So you're going to read them like a normal textbook instead of what you would normally do, which is read directly off the blog. So, but they're all online. So the first thing we're going to do are what are the causes and effects of water pollution, right? So water pollution comes from point and non-point sources. So you need to know the difference between them. That's a big thing on the ACE exam. So point sources are things that are located at specific places. They're easy to identify, monitor, and regulate. And so we can see some examples on the next slide. Let's see, not the next slide. Here's an example of a point source. So point source, and this is paint, all right, would be anything that basically can trace back to one single point. Oftentimes these are dumped from a site or in an industrial waste. Hopefully it's treated ahead of time, but if it's pollutive, it's probably not treated and just dumped in. So from a certain pipe. These are easy to go and find. You can go back, you can just keep doing testing. The concentration of the chemical or whatever's in the water, as you get closer and closer to the point source, gets higher and higher, and finally at your highest point, you look up and there's a pipe, and that's probably where the stuff's coming in, and then you can find out who's dumping it in there and get them to stop. So point sources are much easier to regulate. This can be anything like this, like paint. This can happen with any kind of toxic chemical, that's some kind of waste from an industrial process as well. It has to be gotten rid of it somehow, but being dumped into a water body is not healthy for anybody. So then we have non-point sources, and those are way, way harder to identify. These are going to be broad, diffuse areas. They're expensive to clean up. Your examples of this are going to be like farmland, where maybe somebody's using a pesticide for crops. If they're overusing the pesticide, it's not going to go in at one place, right? You got a large amount of farmland, and so it might be going into the river. Water flows downhill; it goes to the lowest point. But what is that lowest point? Is going to be, the entire river. So it could be entering at multiple points. So basically, your non-point sources are going to be things that are polluting from runoff. So they are much harder to identify. So non-point sources, like I said, agriculture is a leading cause of water pollution in terms of non-point sources. This can happen, proper agricultural practices, you don't have this. It's when you have improper or you're overdoing something that it happens. So this is like sediment eroded from the lands. So when you're churning up the dirt, if you're not taking care of it, you're tilling too much, the sediment can flow down and it can basically clog up the waterways. Fertilizers and pesticides, over-fertilizing, overusing pesticide, and then bacteria from livestock and food processing waste. When you have livestock and they create their waste, if you don't store it properly, of course it will run off and can put a lot of bacteria into the waterways as well. Industrial facilities can also have non-point source pollution if stuff's being stored on site, and again, if it overflows, if their waste is being stored on site and overflows, you can get non-point source pollution there as well. Also mining, a big thing about mining is you go in, you dig up the land, and of course when you move all that soil, it becomes loose. Any kind of wind or rain can erode that into the waterways as well. Other sources of water pollution could be things like parking lots. Parking lots which are impenetrable. You got asphalt. So whereas the ground, normal ground, things can seep into the ground and get naturally filtered out. a asphalt, anything that goes on there, for instance, oil dripping from cars, any kind of leaks, anything that's left on the asphalt, can then be washed into the waterways as well. Human-made materials, a big thing right now is plastics. Plastic, especially like plastic bags and straws and things like that. Things that are light and don't just stay, like even if you take them to the landfill, they may fly away, they get into the waterway. You may have heard of the Great Pacific Garbage Patch. It's a large area in the ocean where plastic has accumulated. And now we're concerned with things called microplastics. As these plastics degrade, they don't just, go away. They've been turning into very, very small pieces of plastic that don't degrade very easily and are able then to be digested by animals, and then they don't leave the digestive tract, and so they just kind of accumulate in animals and can kill them. And climate change due to global warming is exacerbating these problems for water pollution through evaporative losses and different things we will talk about later. So again, there's the point source pollution. Here's an example of non-point source pollution where you had farming on the sides, and what you have here is sediment loss. So the sediment moved during a rain event into the riverway, and now where the river used to be very wide, it's now very narrow because it's been mucked up by soil. Major water pollutants do have harmful effects. So what are the major water pollutants and what do they do? 3 million people die every year, mostly under the age of 5 from waterborne illnesses. And infectious disease organisms can contaminate your drinking water and cause major issues. And you can see some of the stuff here that we have, the different types of water pollutants. You got infectious agents like pathogens, and those are your viruses, bacteria, parasites, and those can come from human and animal waste. So if human and animal waste gets into the waterway, this can then, of course, if people aren't using treated water, like here in the United States, we use treated water, and a lot of LEDCs, people will just go down to the river and get their water. And if that is a discharge point for human waste, or if it's getting non-point source pollution of animal waste, people can get big time sick from there. There's also oxygen demanding waste that deplete dissolved oxygen needed by aquatic species. That's going to be a lot of your fertilizers, and biodegradable animal waste are going to demand that oxygen, take the oxygen away from the water. And that's going to come from sewage again, animal feedlots, food processing facilities, and pulp mills. Plant nutrients. So the plant nutrients are the fertilizers. And what happens with that is called eutrophication. We'll talk about that a little bit more later, but you've got basically, that's plant food, but it's also algae food. And so if you put too much in there, the algae will just multiply and multiply and multiply and multiply and multiply. You'll have a green carpet on top of your lake or river or wherever, ocean, and that basically then will consume all the oxygen and block any light from getting in. Those are in the forms of nitrates and phosphates, which is why we test them during water quality. Those again come from sewage, animal waste, and fertilizers. Organic chemicals are things like oil, gasoline, plastics, and pesticides, and those come from industry. Inorganic, you got acids, bases, salts, and metal compounds. All those things can cause major issues. Sediment is going to be soil and silt, and that comes from land erosion, and that can disrupt photosynthesis, food webs, and other processes, and make basically your flow of water less. And like if you murky up the water, you can disturb photosynthesis of underwater plants as well. Heavy metals cause cancer, disrupt the immune and endocrine system, and you've got lead, metal, mercury, and arsenic with that. A lot of times those can come from unlined landfills. So landfill is where your trash goes. Supposed to have a liner underneath, but sometimes old ones or maybe even newer ones, and maybe especially in LEDCs, won't have that liner there. And so anything that's in that trash will get leached into the ground as water comes into contact with it. And then thermal, this happens around electrical power plants, and basically you're changing the heat of the water. as you take in water from the power plant, you also discharge back out there, but when you discharge, it's hot. This is why if you go up to by the power plant in Tampa and Apollo Beach, they have that manatee viewing area. It's not like a natural manatee viewing area. It's because the species or the water is super warm because there's a power plant right there. And it's cool because the manatees come there, but it can be harmful in different ways as well because you're changing the ecosystem. So here are some common diseases transmitted through contaminated drinking water. You should know some of these. Definite big one around the world is cholera. That's a bacterial disease, come from drinking water that's been contaminated with a bacteria. And that's where you get diarrhea and severe vomiting, dehydration. And so what happens here is that you can't retain the water because you're just losing it as soon as you drink water. So if this bacteria is in there, you're just losing all water. You're not able to retain it, and people actually die a lot from that. You got dysentery and detritus. Viruses, things like hepatitis B, can come from water that's been contaminated with there. Protozoas can cause the same type of thing with that cholera, with the diarrhea and the throwing up and things like that, and can also cause liver disease. And then you can get parasitic worms, which then can affect your digestive tract. So a lot of things can be present in the water, and especially come from human waste, a lot of these things. So it's a big, big, big deal to get human waste treated, which we'll talk about. So we do test water for pollutants. Nice thing in the United States is that we have a big regulations as far as what can be in the water. I'm sure you guys have all experienced, maybe not even experienced, but you've all seen on the news, don't go to Venice Beach on this day. There's like some kind of advisory, and that's because they'll find fecal coliform in the water, and they're like, all right, guys, somehow fecal matter got into the water. It may not be safe. Let's get this thing cleaned up. Let's find out what the source is. Oftentimes, there'll be an overflowing septic tank from someone's house, or it might be even like too much dog waste can get into the water. That can be a problem as well. So make sure you pick up your dog's waste if you have a dog. So what they'll test to determine water quality, like we've talked about in class, and some of you have even done for your project, we'll test a variety of factors to determine the quality of the water. We test the dissolved oxygen, how much oxygen is in there, how well does that support life. We test the coliform bacteria. That's not one we do in class because it's a little bit more invasive, but that's where you test the fecal, basically bacteria, how much is in there. And then we do chemical analysis of nitrates and phosphates because, again, those are the plant foods, so those can cause eutrophication, basically dead zones in the water. We test for temperature change. We test for turbidity, which is going to be the murkiness of the water. We also test for total dissolved solids, which is going to be the amount of ions in the water, which is basically the amount of stuff dissolved. And we'll test for other chemicals as well. All right, so if we look at dissolved oxygen just as a major factor, if we look at the parts per million, now this is kind of crazy, right? This is parts per million. So if you have 1 million parts of water, the amount that needs to be oxygen out of 1 million only needs to be 8 to 9 for it to be high quality. 8 out of 1 million, 9 out of 1 million, okay? So it's not a lot. However, it's very, very, got a very low tolerance of pain, basically. So if you get down to 4, you're gravely polluted. Even if you're 6.7 to 8, you're slightly polluted in terms of your parts per million of oxygen. So just a slight change in this can really impact the water. And down in the yellow to orange to red areas, you're going to have a lot of dead fish. All right? So what are the next, this isn't the next section, this is just the next section in the book, so this is still under our first key question. What are the major water pollution problems in streams and lakes? So we're going to look at those real quick. So here's where we're going to be looking at nutrients and pollutants and how they affect the water. So we're going to look at streams, right? And a stream or a river can cleanse itself if we don't overload them. So they can take a certain amount of pollution and clean themselves, but it does take time and it can be an issue. And what we have here is we have this thing called an oxygen sag curve. So let's look at this real quick. All right. So you can see over in the clean zone in this issue is, or in this river is going to be right around here. All right. Oh, 1 second. Right here. All right. So you got your clean zone where you have 8 parts per million. And that's a good healthy water, and you've got all your nice organisms there. And your BOD, your biochemical oxygen demand, that's going to be how much oxygen is being demanded in there. So what you have here, though, is you have a point source pollution up top, this pipe. It's putting some kind of organic pollutant in there. So what's happening is it's dumping into there. That biochemical oxygen demand goes up. All right, so it shoots way up, and what that does is that starts to decrease. You can see the blue line there. In this first, the decomposition zone, the oxygen levels start to drop because there's more demand for the oxygen. So you get some pollution-tolerant fishes like carp and gar. Then you get the septic zone. The septic zone is where your oxygen bottoms out. You're not going to have much living there at all. You're only going to have fungi, sludge worms, and bacteria. But your oxygen demand starting to go down because you're getting further and further away from your point source of pollution, so you're getting it more and more diluted. Then your oxygen levels start to go up. You have a recovery zone where those pollution-tolerant fishes come back, and then you have a normal clean water organisms as you get back to normal levels. So this is called your oxygen sag curve because your oxygen sags in the middle and then slowly comes back. But these areas where it's septic can be hugely polluted and cause a decrease in fish population. This is a graph you need to know, so you might want to pause here. You might want to, I think you do have to put it into your guided reading, so make sure you do know how that works. We did in the 1970s start to pass water pollution control laws around the world, especially in the United States with the Clean Water Act in 1972. There are a bunch of successful cleanup water stories, like the Ohio Cuyahoga River in the United States and the Thames River in Great Britain. You can read about those in the book. Please do that. Yep. All right, so if we look at a global outlook, in LEDCs, half of the world's 500 rivers in the world are polluted, like pretty severely polluted from untreated sewage, industrial waste, and we've got issues in India's rivers and China's rivers that you can see in here. This is in Iraq, and you can definitely see unregulated water. A lot of the United States waterways looked like this before the Clean Water Act in 1972, but when you have a strong government that is able to make those laws and regulations, you can really get things cleaned up. You can see this is in China. You can see just like waste floating around. This isn't something typically you see in the United States. You can see it from time to time, but usually it does get cleaned up. All right, and when you have unregulated disposal, people can go and basically dump in certain areas just straight into a river, and it is probably illegal, but they need to get rid of their waste, and if their government isn't going to regulate it, you can see things like this happen, and it really does destroy the water, which then impacts the humans. All right, and the Ganges River in India is a holy river where there's religious customs, but there is sewage being spilled into that water because, again, people have to get rid of their sewage, and if they don't have a large treatment plant network set up, your sewage may go untreated to go in there. The government is intervening with waste treatment plants and crematoriums because people would actually put human remains into there. And so this is turning around, but it does take longer in LEDCs. All right, you can see the Ganges River there. All right, pollution problems affecting groundwater and other water sources. All right, so groundwater cannot cleanse itself very well. This is groundwater is the water in the aquifer underneath the ground. It is a source of drinking water, It does get filtered on the way there, but if the groundwater itself gets contaminated, it doesn't clean itself because there's nowhere for it to go. It just sits there. So common pollutants that get into there are fertilizers and pesticides, gasoline, and organic solvents. And the pollutants, what will happen is that if pollutants get into it, it will be dispersed in what's called a plume as it goes out from the source of pollution. Underwater, they don't decompose as well, so there's a slower chemical reaction because there's slow flow, there's less dissolved oxygen, and fewer decomposing bacteria, so this stuff will just sit there. So we really need to keep pollutants out of the groundwater. How long it takes to clean itself, how long will it take to clean itself of that stuff, slowly degradable waste like DDT, and non-degradable waste like lead and arsenic, it won't clean itself. So this stuff will end up being in the waterway. These can come, again, from landfills. They can come from people will do injection wells where they will put their waste deep into the earth, and that can get into there as well. And then that gets in people's drinking water, and that's not good. Right? You can see some of the stuff here. You can see the landfill over here. The landfill will leach into the aquifer. And then you have your water pumping well right here that basically you're getting your water out of, but all this stuff can get into there. Maybe a waste lagoon from an industrial facility, if it's not lined on the bottom, can then seep into the aquifer as well. You have a pumping well. Over here, you got coal strip mine runoff. You've got all kinds of stuff, pesticides and fertilizers, which will run off into the water and will actually seep into the ground. You can have acid rain come in there as well. And like I said before, the hazardous waste injection wells, where people just inject bad chemicals down deep into the earth, that can actually get into the water as well. So all these things need to be regulated. Also, septic tanks as well. You can see here, here's that plume we talked about. Gas stations below a gas station are giant gas tanks. And if those have leaks in them, those can get into the aquifer as well. Actually, that gas can then go up into houses and into basements, and that can cause poisoning as well. And as you can see, that plume, it just gets wider and wider as you go out. And then that, if it gets into the aquifer where there's a well, can get into people's water supply. Please read about China and the U.S. in the book. And we just talked about leaking underground storage tanks. All right. And that's it for this section. Read about the rest in the book, and that's it.